Hi everyone, welcome to this lecture. So in the previous lecture, we discussed the mathematics of support vector machine in detail, and we derived an equation of very important variable, which was k. So the definition of k was that it is the number of units to cross the margin and reach class plus or class 1. So basically, if any of the data point was at the decision boundary and that data point wants to classify as a class 1 or a positive class, it has to move k units in the direction of w so that it can reach to the class 1 or the positive class. So we kept on driving the values and we reached up to this point where the value of k was 1 over w. So this w is the weight matrix or a weight and bias matrix, and this is the magnitude of the w. Now this k is very important parameter for the support vector machine. By adjusting the value of k, we can make support vector machine as a hard classifier or a soft classifier. Furthermore, this k also control the regularization of a support vector machine. So this is very important parameter. So here is the discussion about the k, and we will see how we can set the value of k in order to make support vector machine a hard classifier and a soft classifier. So this is the k. K is the distance which has to be traveled by a data point in order to be classified as a class 1 or as a class positive. So if I increase the value of k, what will happen? Now, if I increase the value of k, it means that hyperplane, which is the positive hyperplane, will go further from the decision boundary. In that case, any point that will be on decision boundary will have to travel more in order to classify as a positive class or a class 1. In that case, the maximum margin will increase. So increasing the value of k means increasing the maximum margin. So if the maximum margin is increased, it means the support vector machine becomes a hard classifier, and it will be hard for any data point that is present on a decision boundary to be classified as a positive class. In that case, this support vector becomes further away from this decision boundary. On the other hand, if I reduce the value of k, if I make this small, that is the value of k is small, in that case, the distance between the decision boundary and this positive hyperplane will be decreased. In that case, it is easy for any point which is at a decision boundary to cross the decision boundary and enter into the region of a positive class. In that case, the support vector machine becomes a soft classifier. So we can see that by increasing the value of k, we can make soft vector machine a hard classifier, and by decreasing the value of k, we can make the soft vector machine as a soft classifier. When it becomes a soft classifier, so it means the distance between this support vector and this decision boundary decreases. So this is the adjustment of the value of k in order to make support vector machine a soft classifier or a hard classifier. The other thing is, we know that if we increase the value of k, or if we want to increase the value of k, in that case, we have to decrease the magnitude of this weight matrix. And we know that when we decrease the value of weights, or when we decrease the value of weight matrix, so that process is called the regularization. So if you remember, in a ridge regularization, or which was the L2 regularization, we had the parameter lambda. So lambda was attached with w, and the purpose of lambda was to reduce the amount of the w so that we can avoid the overfitting. So basically, this parameter k also controls the overfitting and the regularization of a support vector machine, in addition to make a support vector machine a soft and a hard classifier. So in order to avoid overfitting, we have to reduce the value of weights. It means if k is large, in that case, there is less chance of a for a soft vector machine to enter into the overfit condition. So when k is large, it will be a good model, and in that case, it will also be a hard classifier. In that case, the maximum margin will also be greater, or maximum margin will be more. And this positive hyperplane will be at a large distance at compare from the decision boundary. So in this lecture, we see that the k is the most important variable for controlling the functionality of the support vector machine. If we increase the value of k, it means the maximum margin will be increased and support vector machine will become a hard classifier. On the other hand, if we reduce the value of k, in that case, the maximum margin decreases and support vector machine will become a soft classifier. Furthermore, by reducing the weights, we will be able to increase the value of k. In that case, it will provide the regularization to the support vector machine in order to avoid the overfitting. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.